So we are given a block of mass 200 kg being pulled on along an inclined plane of 30 degree by a force of 2 kilonewton acting at an angle 20 degree from the inclined planes. So given the coefficient of kinetic friction of the plane is 0.4, so given the coefficient of kinetic frictions mu k is 0.4, we are going to determine the normal force N, and then the net force, the summation of force, and then the acceleration of the block. So since we are going to calculate the acceleration of the block, then I understood I'm going to apply Newton's second law. And then the time taken for the block to travel 30 meters from rest. So class, because we want to calculate the accelerations of the block, then we might predict the accelerations, where is the motion of the block. So we might predict that under the action of this external force, so the block might accelerate upwards along the inclined plane. Okay, so the block might move or accelerate along the inclined plane. So how we are going to solve this question? We are still going to follow the problem solving step. Start with the FPD, we choose our axis and resolve any forces is needed, then only we write out our Newton's law equations. So we start with our FPD. So the block have mass, so we are going to have weight acting straight downwards. Then the block is put on a surface, so perpendicular from the surface, we have normal reaction force N. Then we have a applied external force, which acting at an angle 20 degree from the inclined plane. And then since we are given the coefficient of kinetic frictions, then we understood that this surface is rough. Okay, the surface is rough, so there will be friction acting. Then we predict that under this action of external force, the block are going to move up along the inclined plane. So we assume the friction is acting in opposite direction, downwards. Okay, the friction is acting downwards. So we have Fk. So we might assume along the inclined plane is our x-axis. And perpendicular to the inclined plane is our y-axis, alright? So after we identify our axis, then we are going to see obviously our normal forces lie along the y-axis. Frictions is lie along the x-axis, but F is at an angle 20 degree that we can resolve it. Okay, so given the angle of inclined plane is 30 degree. Okay, so because this is a right triangle, so here will be 60 degree, then here will be 30 degree. Alright, so now we can start to resolve the forces. We can resolve F into two perpendicular components, X and Y. So we have the component X, we have 2000 cos 20, and then component Y, 2000 sin 20. Same goes for the weight. We can resolve it into component Y and also component X, okay? So we are going to have weight W cos 30 and W sin 30. Alright, so we have do our resolving. Okay, then class, for the first question, we want to determine the normal force. So the normal force is acting along the y-axis. So focus on all the component of forces along the y-axis. So we write out the Newton equation, but for y-axis, we are not going to have any motion. There will be no motion along y-axis. So summation of force along y-axis equal to 0. So we are going to have N, okay, N plus with 2000 sine 20, okay. Then we have W cos 30 downward, so we have to minus W cos 30. So this will equal to 0. So N plus 2000 sine 20. How we calculate weight? Weight is equal to mg. So we are going to have the mass of the block 200. G is 9.81. Cos 30 equal to 0. Then we can solve it using calculator. So we will get the normal force will be 1015 Newton. Okay. Then for the second question, we want to determine the net force. So the net force is directed along the x-axis. The net force is directed along the x-axis. So we are going to have summation of force along the x-axis will equal to, so what forces is acting along the x-axis? So what forces is acting along the x-axis? So you just focus on all the component of forces along the x-axis. So the summation of forces, the net force along the x-axis will be 2000 cos 20 minus W sine 30 minus Fk. So that one will be the net force acting along the inclined plane x-axis. So then we know that W is mg, Fk is mu kn. So we put in the value 2000 cos 20 minus 200 times 9.81 sine 30 minus mu k is 0.4. The normal force we already calculate just now, 1015. Okay, the normal force can take from the answer question A. Then we can do the calculation for the net force along the inclined plane or the x-axis. You will get the value is 492 Newton. Alright. Then question C will be quite straightforward. We understood that the net force will contribute to the acceleration, so we might apply Newton's second law. Summation force x-axis equal to ma. So the net force along the x-axis along the inclined plane is 492. So the mass of the object is 200 multiplied accelerations. So we can get the accelerations is 2.46 meter per second squared. Meter per second squared. Okay, so we get the acceleration. Then question D, we need to calculate the time taken for the block. We need to calculate the time taken for the block to travel a distance of 30 meters from rest. So the keyword rest will telling you that the initial velocity of the box is 0 meter per second. So because we understood that the block is travel straight up along the inclined plane, so in order to solve question D, we can apply kinematic equations. So given that we want to find the time taken in order to travel a distance of 30 meters. Initially is at rest, so the velocity is 0. Then we have the accelerations of the block. Calculate from question C is 2.46 meter per second squared. So we can apply kinematic equation S equal to ut plus half at squared. So our u is 0, so this one cancel. Our displacement is 30. So I'm left with half a is 2.46. Then t squared. So I might calculate the t. So I'll get my t is around 4.94 seconds.